So,
all right, welcome to this brief interview brought to you by Säkerhetspodcasten and SecT. We're interviewing the speakers during the breaks, and now we're having Zoz Brooks here with us, who just delivered an awesome and spectacular talk on how to destroy data. Basically.
yeah, I was thinking maybe we should rename you to Dr. Destructoid or something like that.
Yeah.
It has a nice ring to it.
Yep.
And I am a doctor.
I think
so.
it's a villain in something already.
So you're a doctor in physics or chemistry?
Electrical engineering and computer
Electrical.
science.
Okay.
Yeah.
So
in robotics.
All right. That's boring. That's what
I think robots are pretty cool.
They are. That's what I studied. Well, not robotics, but electrical engineering. Anyways, before we get into what your talk was about, we would like to ask you how you got into security and this field. And
Yeah, I don't really most of the time work in the field. So it's just a casual interest. But basically, I've always been a hacker.
Yeah.
I've always liked to know how things work, take them apart, and use them in ways that were never intended. And sometimes that's getting places you're not supposed to go, or making it do things it's not supposed to do. And sometimes it's just, for the love of figuring out how it works and
Cool.
being able to use it in your own projects and stuff.
so out of curiosity, basically.
Yeah, I guess you could say that.
Cool.
I've just.
So speaking of hacking, what's the most the coolest hack in history, in your opinion?
In history, well, that's a really hard question, because hacking is something that's inseparable from technology, and technology is constantly changing, right? So I think it's hard to nail down what's the best thing ever, but cool things keep happening all the time, right? So I think that. Historically speaking, the phone phreaking, the whole general nature of phone phreaking is the coolest, because at that time, the phone system, the international phone system, was the most complicated machine that humans had ever built.
Yeah.
It was just amazing, and all these people had to figure out how it worked with very little inside information, and then how to make it respond to their commands. So it's sort of like the internet, but fundamentally a bit different in terms of the documentation that was available, and the fact that the internet, you can do anything, right? That's the whole goal. But the phone system wasn't designed to do anything really other than route calls, but people used it for all kinds of crazy stuff. So I would say phone phreaking is a cool area. But recently, there's just lots of great stuff coming out all the time. And two recent examples are the guy who figured out how to hack the Onity hotel door key locks, because that's an example of just a super high impact hack that with pretty basic hardware he compromised locks all over the world. And that's not so easy to do with physical locks, but electronic locks give you the chance to just destroy everything. And then there was a cool talk at DEF CON this year that I really liked. It was the kind of thing where, like, my mom called me up afterwards and she was like, can you build one of these for me? Because I've got one that I need to open to. A guy had built an auto safe cracker. And auto dialers are nothing new, but his wife had given him a safe, and he was like, well, we don't know what's in it, I bet I could crack this. And he'd used like kids' robotics parts to build an auto safe cracker. And I thought that was just like a really nice hack.
Cool. Yeah.
I hotel safes, when people demonstrate opening them with a potato.
Yeah.
That's like, okay, there is an explanation for this, but it's still so stupid and so cool that you can just smash a potato into a safe until it opens.
Yeah. That's sort of the ultimate. There's not much that's more low tech than a potato.
Kinetic attacks, for the win. All right. Anyway, your talk today was about destroying data, and in a very physical sense. You were talking about the challenge to destroy data from a hard drive in 60 seconds, and trying to contain whatever method that you used, and there were some very, very spectacular ways, of course, and kind of like in a Mythbusters sort of way. blowing up the hard drives and
I have felt that on the contained you have a very loose definition of contained.
Well, a lot of this comes down to like my experience and the people I was working with and our judgment of whether it was feasible, because obviously we didn't go fully to proof of concept.
Yeah.
But I feel pretty confident that we could build something that contained it within the original
Yeah,
specifications there, right?
cooler hardware and
Like 1U
extreme metal
is nearly 3 inches,
Yeah.
right? And nearly 3 inches of reinforced concrete is a pretty serious slug to confine something with.
But I was thinking the destruction. What it looked like you had a lot of fun doing all these experiments. But what put you on to this task in the first place?
Well, I got the idea from a DEF CON talk that I'd seen a few years before. That was done by Deviant Ollam and Bruce Potter. So it was those guys are both really funny. It was a really funny talk. But at the end, it made me think. And some of the best talks do that, right?
Yeah.
They make you think. Well, how would I approach this? Because they didn't try everything. And I'm somewhat uniquely situated in that I have really good contacts in the explosives, in various explosive and pyrotechnic related industries.
Mm-hmm.
So I knew I could do this kind of work. And as I said in the talk, also I'd been thinking for a long time about 3D printing high explosives, and I wanted to do that too. So those motivations came together, and I thought, well, let's do this, right?
Yeah.
Let's just stop talking about it and thinking about it. Let's actually make it happen.
Cool.
And have some fun with it.
Yeah.
But from my understanding, you accidentally set a rug on fire.
It's true. Yeah.
But was that the worst, or did you? Was there? And you burned your fingers at some point. But did you ever get afraid at some experiment there? It did go too much in some direction that or something like that?
I didn't get afraid because although you might not know from the presentation, I'm actually a pretty careful person when it comes to this type of stuff, and especially the high explosives work. We actually did that under the supervision of the local bomb squad in Colorado. So we had a police officer with us the whole time, and there was no way, as well as people who were licensed to handle and use high explosives. So there was no way that any corners were going to be cut on that work in terms of safety. So we were very, very cautious about everything. All those shots were done with us over a hill of earth and behind a vehicle. Yeah. So there was no direct line that a fragment could travel. We did everything by the book. And that wasn't so. There's no book for thermite and stuff like that. So the earlier experiments were a little bit more goofy, but we still followed appropriate safety protocols to make sure that no one was ever in any kind of serious danger.
Yeah, your presentation contains some very spectacular high frame rate footage. You weren't afraid of putting expensive equipment close to these explosions?
Certainly. The owners of that expensive equipment were concerned, but once again, we just did everything properly. Because when I set out to do this work, I said right from the beginning, it's really important that we get some high-speed footage of this, so that the audience can really appreciate it, and so that we can also see what's going on. Mm-hmm. So I knew from the beginning I was going to need to use these cameras that cost $25,000 or more. So you just don't take risks. Yeah. So we actually. I didn't show it in the presentation, but we built protective enclosures for all the cameras. The only camera actually that wasn't protected was my camera, which I put on a tripod, and I just was like, well, if it gets hit, it gets hit. I'm willing to lose it. Yeah. But the other ones were in metal ammunition boxes with bulletproof Lexan shields on them. So we just, I had told the people, if we break the camera, I'll pay for it, and I didn't want to be liable for $25,000, so we did everything right.
Yeah. Well.
Yeah, that was it was 100,000 frames per second footage. That was on Phantom camera or something, I guess.
That's actually beyond a Phantom. Yeah. So actually, that footage right at the end of the can crushes, that was something we shot for a Discovery Channel TV show called Time Warp, which I was a segment producer on. So we had done a big sequence for that show on high voltage things, and some of it made it to air and some of it didn't. So one of the main reasons that I included that in there was I just wanted people to see how crazy that was, because it was never in the show, I don't think. And we shot all the footage, so I managed to get hold of the footage and put it in there because it's just so cool, right?
Yeah.
So to use electricity to just smash a can like that. And so that stuff was shot on a camera called a Photron SA1 or SA2, and those things are $500,000 cameras. But yeah, so I couldn't have even afforded to rent those, but I had that footage anyway from Time Warp.
Cool. Anyway, in the beginning you were talking about governments trying to collect fragments of hard drives and trying to extract information from those. Really, I mean, in my experience, once a hard drive has been physically deformed, it is very, very implausible that someone would be able to extract information from that. So, have you heard any rumors that there actually is any technology that possibly could extract information from a hard drive? Let's say that you punch a nail through.
Yeah, so that's a really interesting question, and it's something that anyone who does know the answer to isn't allowed to talk about it, right? Yeah. So I guess what I have on that subject is technically rumor. It's secondhand information, but it came from, as I said in the talk, a guy who was recovering intelligence information in Iraq after the American invasion, and he was under instructions from the NSA to collect and send to them any storage material that had not been both crushed or shredded and burned. And they told him, because they didn't want to, presumably they don't waste this guy's time. Mm-hmm. So they told him, if you find a disc that's been crushed or cut in half, whatever, send it to us because it's still useful to us. Okay. So the implication is that they have methods of recovery, and I, as a robotics person, I can think of ways that I would approach that problem, mm-hmm. right? So I could think of designing a system that took a platter and 3D imaged it to get the exact curvature and then swept a robot arm with a read head over the top of that at the read height. It's totally feasible to do from a control perspective, and modern drives are so data dense.
Yeah, that's another thing.
A small piece, still would potentially hold a lot of data. Like an individual file could reside in a very small piece of disk.
But on the other hand, I mean, the data density itself poses a problem in recovery because you don't have tracks anymore like you did on the old type of hard drives. I mean, you're relying on magnetic information that it's actually like a voice coil that positions the read head on the platter. So I would think it would be near impossible, at least I think for a civilian authority it would
be. Sure. But how many tens of millions of dollars, if you threw that at the problem, could it become tractable, right? Because the intelligence budget in the United States is many hundreds of millions of dollars.
And I mean, it doesn't need to mean that they think it's recoverable today. Yeah. When you go by military and they have 30 years expectancies and so it could be.
They expect that in the future we might have technology that could recover something.
And it could be like maybe they do the first triage and these like very unlikely we ever can recover. And these are like slightly possible that if we throw a lot of money on it, and then if they get over intelligence that says drives recovery in this area might be very, very important, then they might push those extremely expensive measures on those particular disks. Yeah. Yeah. So if they recovered 100,000 badly damaged drives, maybe just 5 actually went through the most expensive, most complex procedures.
Yeah.
And a lot of it just depends on, what's your personal risk comfortability.
Yeah.
Right? If my life was in danger from the material on those drives, or if my freedom was in danger, if I was a criminal running a darknet market or something like that, then I would be very paranoid.
Yeah.
Even excessively so. You know, it's just like why take a risk you don't have to.
No, that's true. I mean, you can never be too sure, and of course, my experience is from the field of forensics, and there you have conventional methods, which means that a damaged drive or damaged read heads or something like that's completely possible to recover, but it becomes almost impossible if the platters are damaged or somehow physically have any defects on them, because they're going to destroy the equipment that you're using to recover the data.
Yeah.
But yeah, I mean, given infinite budgets, it might be possible. Possibly plausible, at least.
Yeah. I mean, I think it's an interesting thought experiment.
Yeah. So, anyway, thank you for taking this time to talk to us during this interview.
Thanks for having me.
And we'll go down and listen to some of the lightning talks.
Yeah,
so,
I'm psyched.
Do you have any like what kind of destruction or something you would like to do that you haven't done yet? Is there
what's in line?
Is there anything you have like imagined you would like to do but haven't done yet? Since you have done bombs, and you have done crazy physics things to wreck things, is there anything you feel like this is the thing I haven't tried yet?
Yeah, there's a few things that are not all like straight destructive things, but kind of interesting effects. I'd like to that stuff at the end with the can crushing.
Yeah,
I'd be super psyched to try and do that at scale and try and do it on something the size and weight of a full 5 1/4 inch.
I saw a demonstration. I think it was Physics Girl on YouTube where they took a penny and they did something strange magnetic electricity thing and shrunk it.
Yeah, so that same rig for crushing cans you can also use for shrinking quarters. And we did that also on Time Warp as part of that same shoot. And so I have some video of that too at a really high frame rate. But again, it's like really hard to see what's going on because at 100,000 frames per second, it still happens in one frame, and this coin doesn't get a lot smaller. It gets a little bit smaller, so it's not as dramatic as the can crushing. But it's really cool because no material disappears. The coin gets a smaller diameter, but it gets thicker because the material stays constant.
So you don't think this is the new solution to data compression?
If matter is data, there's no compression. The same amount of matter is there. But one thing that's cool about that, if you take a euro coin, a bimetallic coin, and you shrink it, they shrink at different rates. So the middle part pops out. So I have one at home actually that I shrunk on a quarter shrinker, and now it's the two separate pieces.
Cool. Yeah, it would be fun. Now they decommissioned the high voltage lab at Chalmers University, but it would be cool to get access to that equipment and see what you could do with a hard drive. Yeah.
And any of these things are totally accessible to the hobbyist. They're just expensive.
Yeah.
Buying a big bank of pulse capacitors, there's a fair outlay of cash to do that, but you can do it.
Yeah. Cool. Well, thank you for giving this interview, and have fun at the rest of the conference.
Thank you. Yeah.
Thanks.
Good times.
Thank you. All right.
All right.
Over and out.
Over and out.